Number 2, we first need to multiply the coefficients together. 3 times 3 is 9. And then when we're multiplying two things with exponents together, we add the exponents. 2 plus 4 is 6. We'll follow the same pattern on number 4. We multiply the coefficients. 4 times 2 is 8. 4 plus 3 is 7. Because when we're multiplying, we add the exponents together. Number 6, we're using the rule where we have an exponent outside the parentheses. This is where we multiply the exponents together. Remember, there's always an exponent even if one is not written. So this is 4 to the first. So 1 times 2 is 2, giving us 4 squared. 3 times 2 is 6, giving us x to the 6th. I would accept this answer. You could also type 4 squared in your calculator and give it to me this way. So I would accept either one of those. Okay, we'll follow the same rule on number 8. Again, remember there are exponents with every piece. That's 2 to the first, m to the first, n squared. 1 times 4 is 4. 1 times 4 is 4. 2 times 4 is 8. Then you could write it that way, or you could type 2 to the 4th in your calculator and give it to me this way. Either one of those is fine. Now we're switching to the division rule. Well, just like up here, we just multiplied the coefficients together. 3 times 3, 4 times 2. Here, we'll just divide the coefficients. 4 divided by 4 is 1, so those just cancel out. And when we're dividing, we subtract the exponents. So we do 4 minus 3 is 1. And you could also just write that as y. You can write y to the first, or just y. Number 12, 4 divided by 2 is 2. This is the only place we have an x, but if you look at the directions, it says we should only have positive exponents. To make this exponent positive, we have to move it to the top of the fraction. That'll make it a positive 3. Sorry, I have to keep clearing my throat. 4 minus negative 1, because we subtract when we're dividing. So 4 minus negative 1 is 5, so we get y to the 5th. So we end up not having a fraction here because 4 divided by 2 is 2 over 1, so we just have 2 on top. The x moved to the top, and this y also ended up combined with the one up top. Okay, 14, 3, that's the only coefficient, so it just stays as it is. You've got to remember, this does have an exponent. This is a 1. So we subtract 4 minus 1 and get x to the 3rd. This is the only y, so it doesn't change. It just stays as y to the 4th power. On 16, we need to apply this power of 4 first. So this is 2 to the first. 1 times 4 is 4. 2 to the 4th. 2 times 4 is 8. 4 times 4 is 16. All that's over 2b. Okay, now we're not done. We have to still simplify. In your calculator, 2 to the 4th will give you 16. 16 divided by 2 is 8. This is the only a, so it just stays as it is. With the b, we've got to remember this is a b to the first, so 16 minus 1 is 15. Okay, 18, we have to take care of this cubed first. Got to take care of the exponents outside the parentheses first. So 2 times 3 gives us 6. 4 times 3 gives us 12. We put that all over x cubed, y to the 4th. Then when we're dividing, we subtract exponents. 6 minus 3 is 3. 12 minus 4 is 8. Okay, switching gears now. The only way we can combine these is if they're like terms. Now at the moment they're not. We have to have the same number inside the radical if we're going to combine them. So we'll try to see if we can simplify this. So 12 can become 4 times 3. And I chose 4 times 3 because 4 is a perfect square. 27 become 9 times 3. So the negative 2 just stays as it is, times square root of 4 is 2, times the square root of 3. We don't know the square root of 3, so we just leave it inside. Then this minus 2 just stays as it is. Square root of 9 is 3. Square root of 3 is just the square root of 3. Negative 2 times 2 is negative 4. Negative 2 times 3 is 6, or negative 6. So we finally, after all that reducing, have like terms. They're both square root of 3's. Negative 4 minus 6 gives us negative 10. So we have negative 10 square root of 3. These are like terms. Both are the square root of 8. And negative 3 plus 3 is 0. It's not square root of 8. It's not just the 3's that go away. Because you have negative 3 of these. And if you add 3 of these, then the result is to have none of these. So you have 0. Okay, this one is similar to 20. We're going to have to simplify first because they're not they're not like terms. We don't have the same square root. 54 can be rewritten as 9 times 6. And then there's no numbers that multiply to be 6 that include a perfect square. Because all we'd have is 2 times 3. Neither of them are perfect squares. So we just leave it as it is. Square root of 9 is 3. Square root of 6 we don't know, so we leave it inside. 3 times 3 is 9. And now we do have like terms. They're both square root of 6's. So 9 minus 2 gives us 7 square root of 6. Okay, this one's very similar. 54 becomes 9 times 6. We can't break down 6 any farther. Square root of 9 is 3. Negative 2 times 3 is negative 6. Negative 6 plus 3 is negative 3 square root of 6. Okay, when we're simplifying, we're not allowed to have a square root in the denominator. To fix that, we multiply the top and bottom by the square root of 3. 2 times 3 is 6. And the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is 3. And you're welcome to jump straight from this to this if you're able to see that. Square root of 3 times square root of 3 is 3. Okay, on 30, same process. We have a square root of 5 in the bottom. So the way we'll fix that is multiply the top and bottom by the square root of 5. Square root of 3 times square root of 5 is the square root of 15. Square root of 5 times square root of 5 is 5. Because the square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 is 5. And we cannot reduce this any farther. 5 does go into 15 and 5, but we cannot reduce when one number is inside the radical and one's outside. Okay, 32. We need to multiply top and bottom by the square root of 2 to fix that issue of the square root of 2 in the denominator. Square root of 5 times square root of 2 is the square root of 10. On the bottom, watch carefully, this 2 right here just stays as 2. And then the square root of 2 times the square root of 2 gives us another 2, which we can then combine and get 4. Okay, when we're distributing, remember we can multiply together things outside the radicals, and we can multiply two things that are both inside, but we can't mix up an outside and inside. So when I do this times the 5, I can do 2 times 5 and get 10, because they're both outside the radical. But the square root of 10 doesn't change because there's no square root it's being multiplied by. Then I just put this plus down. Multiply these two together. 2 is the only number outside, so I just leave it as 2. Square root of 10 times square root of 2 is square root of 20. Now, this 10 cannot be broken down any farther. 2 times 5, neither of those are perfect squares. But this one can be broken down farther, because 20 is 4 times 5. Square root of 4 is 2. Square root of 5 we don't know, so it just stays square root of 5. So we get 10 square root of 10 plus 4 square root of 5. And those are not like terms, and they can't be broken down any farther, so we leave it just like it is. Okay, here, these are all square roots. We can combine all of them as far as multiplying is concerned. 2 times 5 is 10, so we get square root of 10. Square root of 2 times square root of 2 is 2. Square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 equals 2. Last page. So we're still distributing on these first couple. So square root of 5 times 2, we cannot combine those because one's inside the radical, one's outside. We just keep the minus sign from right here. When I multiply these together, this 5 just stays like it is because it's the only outside piece. Whereas this 5 and this 5 can be multiplied. Square root of 5 times square root of 5 is square root of 25, which is equal to 5. So our final answer is 2 square root of 5 minus 25, because we can multiply those 5's together. Okay, 40. Square root of 5 times square root of 2, they can be combined because they're both inside the square root. So we have the square root of 10. Square root of 5 times 3, they cannot be combined. So we just write 3 times the square root of 5. Okay, 42. We'll deal with the numbers first on the rest of these, then deal with the variables. So 27 can become 9 times 3. The square root of 9 is 3. This 3 just stays inside. This is into the first. So we say, okay, how many times does 2, the understood 2 right here, go into 1? Well, it doesn't. So we can't pull any ends out. This one end is left inside the radical. Okay, 80. I'm going to list all the possibilities. 2 times 40, 4 times 20, 5 times 16, and 8 times 10. So we do have 2 perfect squares, but we want to use the bigger one, which will be the 16. So we'll write this as 16 times 5 times n. Square root of 16 is 4. Square root of 5 we don't know. And just like it was in number 42, there's just one n. 2 won't go into 1 at all, so that one n is just left inside the radical. Okay, 46, we do 3 times 25, 5 times 15. I think those are the only possibilities. So 25 is the perfect square we'll want. So we get the square root of 25 times 3 times x times y. The square root of 25 is 5. Square root of 3 we don't know, so we leave it inside. And there's just one x and one y, so 2 can't go into either one of them, so both of them stay inside the radical. $48. We don't have to break this one up. 100 is a perfect square. Square root of 100 is 10. And 2 goes into 2 one time, so we can bring one x out front, and it goes in evenly, so there's no remainder, so there's no x inside. But there's only one y, and 2 can't go into 1, so that one y is just left inside. Okay, last one. 50 can be 2 and 25 or 5 and 10. So 25 is our perfect square. So we'll do the square root of 25 times 2 times u squared times v squared. The square root of 25 is 5. Square root of 2 we don't know. 2 goes into 2 one time, so 1 u can come out. No leftovers. 2 can go into 2 one time, so 1v comes out. No leftovers.